Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through the Unit 11 group review and then probably the extra practice after that. All right, so this is on, looks like systems of equations. And yeah, let's split this into some smaller videos. Probably do, I don't know, the first four. Oh, what the heck? We'll do the first six. Yeah, we'll just do the first page on this one. Okay, so you can use either method. That's wonderful. I hate being told which one to do. So let's see, which one would I like to use for number one? I think that the one that I would use is probably elimination for this. Here's why. I can like make that 1/2 uh, into a 6 pretty easily by just multiplying it by 12, so like that 1/2 right there. I'm going to make it look like a -6. So then I can cancel it out with the positive 6x. Let's see, is there anything else I would do first? Well, you know what? I noticed that the 6 and the 4 and the 14, all these coefficients, they're all divisible by 2. So first thing that I would actually do to make things a little bit simpler, to make the numbers that I got to multiply a little bit smaller, I would just divide both sides, of this equation and this equation by 2. And I can do that because as long as I do the same thing on the left-hand side of the equal sign and the right-hand side of the equal sign, as long as I do the same thing on that, it doesn't change anything. So that's like the first thing I would do, honestly. I'd get rid of that. I'd divide by 2 on both sides. So like before I even start, I'd try to make my equation a little bit simpler. So let's see, that's 3x and 2y and now a -7 because I divided both sides by 2. Okay. And then now let's go ahead and do the elimination thing. So let's see, I am going to multiply this top equation here, the whole thing, the left and the right-hand side, by 6. And if I do that, 6 times 1/2 gives me 3, and that 3 is going to be used to cancel out that 3x right there, okay? But I've also got to do one more thing. I've got to multiply by a -6 to be able to do that, right? Because if I add the equations together, that'll give me, 0x overall. So multiplying the -6 into everything. So if I distribute that into every single term on the left and the right-hand side, here's what I get afterwards. And by the way, I'm going to write out what happens when I do this multiplication because, after grading these a bunch of different times, like tests like this and quizzes and things like that with systems of equations, the kids that make the mistakes are the ones that just like don't write out their steps, honestly. And it can be a really easy problem like this where you miss a few points that you'll really regret. Okay, so just write out all the steps that you can. So -6 times 1/2 is a -3, so I get -3x from this part. And then -6 times positive 5y, that gives me a -30y. And then -6 times 0 is still just the regular old 0. All right, and then my other equation, I've got a 3x and a 2y, and it looks like a -7. Excuse me. So if I add these two equations together, I'm going to be on my way to solving for y because if I add the 3x and the -x together, that gives me 0x. And then if I add the -30y and the positive 2y, that gives me a -28y in total. And then 0 and -7 add together to be -7. Okay, so then, 0x really just isn't there. But look what this turns into. I've just isolated one variable, the y value, and now I can solve for y. If I divide both sides by 28, -28, I get y is equal to -7 over -28, which reduces down to 1/4. So there we go. There's my y value, 1/4. Now, the cool thing about it is that y value works for this equation or for this equation. And so you can pick whichever equation you want, and you can solve for the corresponding x value. The one that I would pick to use in this particular case is the second equation. And here's why. I'm going to be plugging in a 4th for my y value. And man, that's a really nice number to multiply by a 4th, right? So that's what I'm going to do. I'm going to take the equation 6x plus 4y equals -14. And what I'm going to do is plug in 1/4 for the y value. Okay, so that becomes 4 now times 1/4. All right, so 4 times a fourth. Last time I checked, that's 1. So 6x plus 1 is equal to negative 14. Then if I subtract 1 from both sides, I get 6x equals negative 15. Then if I divide both sides by 6, I get x is equal to negative 15 sixths, which can reduce because both of those are divisible by 3, and I get negative 5 and 2, negative 5 halves. So that gives me like my solution, and you always want to write up your solution as an ordered pair. So like right next to the beginning part, maybe I'd write it up as an ordered pair. The x value is negative 5 halves, and the y value is 1/4. And that should work either way for for the first equation as well. So if you have a little bit of time at the end of your test, and you have a little bit more space, I didn't have much space to write in here, I would take that ordered pair, and you know how I got it from this equation? I would then take that ordered pair and plug it into here to verify that equation, that ordered pair works for this equation as well. Let's see if that's the case. Okay, so let's pretend that we're at the end of the test. We've got our answer, and we want to check our work. All we'd have to do is make sure that when I do this, right, I plug in the x and the y, that I end up with 0. Let's see if that's the case. So 1/2 times negative 5 halves. When I multiply fractions together, I multiply across the top, so that'd be negative 5 times 1, negative 5. And then multiply across the bottom, 2 times 2 is 4. And then 5 times 1, 1/4, that's 5 over 1. So 5 times 1 is 5, and 1 times 4 is 4. Yeah, sure enough, when those add together, we get 0. So this checks out as well. All right, I'm only going to do that for this one, but I want you to know that you can take your ordered pair and you can plug it into the other equation to verify that it's the solution to the whole entire system. All right, so there's our first one, number 1. Number 2, let's see, what would I want to do for this one? Maybe it'd be easiest to solve. Let's go ahead and do substitution. I think that substitution would be really easy because I can take like this fraction expression and I can solve for x like with the most ease. Check this out. So I'm going to get x all by itself on one side. All right, so I'm going to take that one and I'm going to get x all by itself. So I'm going to take all the other stuff, and like move it over the other side. So I'm going to add 3/2 of a y over on the other side. So now I've got 3/2 of a y. And then I'm also going to like subtract 4 from both sides to get rid of like this part over here. So minus 4. All right. And then how do I get rid of that times 1/2 in front of the x? I multiply both sides by 2, right? So if I multiply the left-hand side by 2, I just get x. And if I multiply the right-hand side by 2, 3/2 times 2. The 2's just cancel out, giving me just like 3. So I'd have 3 y's. And then 2 times 4 would give me 8. So that'd be an 8 right there. Okay, so I've got x in terms of y. That's really helpful. So I use that top equation to get x in terms of y. Now I'm going to use this equation here. Okay, so that's just like, rebranding essentially this equation. I'm going to take the x value that's right here. That x value is the same exact thing as that x value. So what I'm going to do is replace this stuff right here with x in this equation. Okay, so let's plug it in. So instead of x, we've got 3y minus 8, and then plus 7y, and then minus 12 equals 0. So we started off with 2 variables, x and y. Now through the process of substitution, we're down to just a single variable. So let's like add this stuff up and see what we get. Okay, so I'm going to combine like terms. 3y and 7y gives me 10y. Negative 8 and negative 12 gives me a negative 20. So then if I add 20 to both sides, I get 10y equals 20. And if I divide both sides by 10, I get y is equal to 2. So there's my y value. And then remember that it's an ordered pair. I need an x and a y. We just found the y value too. So to find x, I've already got this really nice equation down here, that solves x in terms of y. So what I'm going to do is plug the y value in that I just found. So I get x is equal to 3 times 2, and then minus 8. So that's 6 minus 8, which is negative 2. Negative 2, 2. That's my system of equations solution. And if you wanted to, you can plug it back into either of the equations to check your work. But I'm pretty confident that's what it ends up being. All right. Now we've got number 1 and number 2. So let's keep going. Maybe we'll go a little faster this time. Okay, so I've got a bunch of decimal values. Looks like they all go to the 10th place. Remember, just like the 10th place is like that first digit after the 0, right? So we'd have like tens place, hundreds place, thousands place, 10,000ths place, and so on, okay, forever. If the lowest place that you go out of all your decimal values is the 10th place, then I've got just the coolest thing that'll help you out to solve this system of equations. Because you know what I hate? I am not a huge fan of decimals. I'm just not a fan of them when I don't need to use them. Same thing with fractions. I'm not a huge fraction fan. So what I'm going to do is show you methods that I've developed. I was taught them. I didn't develop them myself. To get rid of any fractions or decimals, okay? And I bet it's the same thing your teacher taught you in class. So everything is like all my decimals are in terms of the tens place. So what I'm going to do is any equation that has a decimal in it, it's to the tens place. I'm going to multiply the whole thing by 10. So both of these equations are going to get multiplied by 10, and it's okay to do that as long as I multiply like the right hand side by 10 and the left hand side by 10. Because of that equal sign, I just got to make sure that like I balance it out, that I do it the same on both sides, okay? So I'm going to multiply that top equation by 10, and here's what I would get. 0.2 times 10 is just 2, so I get 2x minus, and then it'd be 0.6 times 10, and 0.6 times 10 is just 6, so 6y equals, and I better make sure to do it on the last one, negative 5 times 10, and that's negative 50, I think. And yeah, look at that, no decimals. That's the trick. Okay, so let's do the same thing on the other one. So multiply by 10, 0.1 times 10, that's 1, so 1x. And then 0.2 times 10, that's 2, so 2y. And then 0 times 10 is just 0 still. All right, and I'm going to claim that either substitution or elimination are equally fun in this case. So you can do whatever you want. I'm just going to do probably substitution. I would do substitution because I've already got like this x all by itself. So all I'd have to do is subtract 2y. So x equals negative 2y. There's my little equation that I can get for x. So wherever I see an x on the other equation, like over here, I'm going to replace it with negative 2y. All right, so here we go. Ready? I'm going to use this one, and I'm going to plug in for x, and here's what I end up getting. Ready? I get 2 times x, and x is secretly also negative 2y, and then minus 6y, and that's going to be equal to negative 50. Okay? 2 times negative 2 is a negative 4, so this turns into negative 4y minus 6y equals negative 50. Combining like terms, I get negative 10y equals negative 50. And then dividing both sides by negative 10 gives me y equals 5. So there we go. We've solved for y with our ordered pair. Our y value is 5. So now we got to get the x value. And for that, I'm going to go right back over to that nice little easy equation that I found for x in terms of y. So I plug in my little y value there. X equals negative 2 times y, which is 5. And negative 2 times 5 is negative 10. So negative 10 is my x value. There's my ordered pair. And once again, if you want, like if you have a calculator, you can go ahead and plug the x and the y value into either of those equations, and the equations should end up working out just fine. Okay, so now we go on to number 4. We've got fractions. So here's what I like to do with the fractions, just like an easy kind of spamming way to get everything done, so you can just kind of do everything at the same time. Take any denominator that you have, all right, and any ones that are in common, just like eliminate one of them, and just multiply all of the denominators together. So 3 times 2 times 7. So 3 times 2 times 7. These are like the ones that I have in the denominator. 3 times 2 is 6. and 6 times 7 gives me 42. So what I'm going to do to get rid of the fractions, I'm going to multiply the top equation and the bottom equation by that number. Okay, that's like the easy way to do it for all fractions in the entire thing. But you can actually, like, if you want, like, you can isolate each individual equation and do the same thing. So, like, notice that my only denominators here are 2 and 3. So I'd multiply the top equation by 3 times 2. So I'd multiply it by 6. And remember, that's okay to do as long as you multiply on the left-hand side and also on the right-hand side. It preserves that equality. So it's okay to do that. And I would do the same thing with the bottom equation. All right. I see a 3 and a 7. So I multiply those two together. That gives me a 21. So 21 would be the one that I'm going to multiply on the left and the right-hand side here. I told you about like the 42 thing because that should work for everything. You know, like if you don't want to really think much, you can always just take all of the denominators and multiply them together. That'll always work as well. Anyways, I digress. I'm going to go ahead and distribute my numbers in here. Let's see what we get. So 6 gets distributed into that x plus x over 3. So there we go. 6 times x over 3. And then 6 also gets distributed into the y over 2. And then 6 also gets distributed into the negative 5 over there. All right. So let's see how that thing ends up, you know, like how it ends up simplifying. So 6 times x over 3 is the same thing as saying 6x over 3. And the 6 and the 3 are both divisible by 3. So what is 6 divided by 3 going to give you? It's going to give you 2 overall. So that reduces down to 2x. Right? 6 times y over 2 is the same thing as saying 6y over 2. And 6 divided by 2 gives you 3. So you'd have 3 y's. And then 6 times negative 5 is negative 30. All right. And then the other one, let's see here. So we distribute the 21 into everything, the left side and the right-hand side. So we get 21 times x over 3 plus 21 times x over 7 equals 21 times 0. We know what that is, right? That's just 0. We can do that one on the fly. Okay, now we've got 21x over 3. 21 divided by 3 is 7, so that turns into 7x. And then 21x over 7. 21 divided by 7 is 3. Oops, that should be a y, shouldn't it? 21 divided by 7 is 3, so that turns into a 3y. And let's see, which one would be the easiest to do between substitution and elimination here? You know what? I'd probably say, since I already have a 3y and a 3y here, I'd probably choose to use elimination. So here's what I'm going to do. I'm going to multiply this top equation by negative 1, right? And then I'm going to add the two equations together. So if I distribute my negative 1 into every single term, here's what I end up with. I'll rewrite it over here in the center screen. So I get a negative 2x, a negative 3y, and then a negative of a negative is a positive, so a positive 30. And then I get 7x and 3y and 0, because that doesn't change the other equation. And if I add these two equations together, combining like terms, 7x minus 2x is going to give you 5x. 3y minus 3y is going to give you 0y. And 30 plus 0 gives you 30. Okay, so let's get rid of that plus 0y because that's useless. So this really just becomes 5x equals 30. So if I divide both sides by 5, I get x equals 6. And just like that, you know, I've got my little x value for my ordered pair. So here we go. X is 6. Let's find the y value. So to find the y value, I can really just choose any equation that I want. I could use the fraction equations if I wanted at the very beginning, or so either of these ones, or I can use either of these ones as well. You know, I always tend to pick the ones that don't have fractions. You know, so I'd probably pick one of these two on the right hand side, and I usually pick the ones with the smallest numbers. So I see like a 0 in here, so I'm probably going to go with this equation. So let's see here. My x value is 6, so it'd be 7 times 6 plus 3y equals 0. 7 times 6 is 42. If I subtract 42 from both sides, I get 3y is equal to negative 42. And I'm pretty sure that if I divided that by 3, I'd get y is equal to negative 14. So that gives me my y value, negative 14. And if you wanted to, you could go back and you could plug either of those, that solution, that ordered pair, in either of these equations, like maybe that one, and I bet that you'd get negative 5 as your result. Okay, 2 more, and that'll be it for this video. Oh, what the heck. You know what? Let's keep the videos kind of short. That'll be the end of this video, and then we'll start up on the nonlinear systems in a second. All right, see you then. Bye-bye.